Hello, in this lesson we'll be doing an word problem based on geometric sequences. So now the first property is that the second term is equal to 4. The second property is that the seventh term is 32 times the second term. So now before we do anything, let's write what is given here. They say that the second term is equal to 4. This means that T2 is equal to 4. T2 is equal to 4. And that T7 is 32 times T2. T7 is equal to 32 times T2. When they say 32 times the second term, they mean that the seventh term is equal to 32 times T2. So now, what is the basic form of a geometric sequence? Is that Tn is equal to ar to the power of n minus 1. The first question says, determine the nth term, the general term, or the equation of the geometric sequence above. So we have to solve for a and r and plug them in the formula to get the answer that is given. So we're going to solve for a and r simultaneously. So now we're going to write it here. We know that Tn is equal to ar to the power of n minus 1. So what is Tn? We said Tn stands for the value found on a certain position. This means that we have 4 as the value, and that is ar to the power of the n is 2 minus 1. N stands for the position, and that is position 2. Hence we say the second term. 2 minus 1 is equal to 1. Therefore, 4 is equal to ar to the power of 1, or ar. Then this gives us the first equation. Now we are going to T7. T7 is equal to 32 times, what is T2? T2 is equal to 4. We're going to plug 4 here. This means that T7 is equal to 32 times 4 is equal to 128. This means that T7 is equal to 128. We're going to plug this in the formula. We know that it's given as Tn is equal to ar to the power of n minus 1. So Tn is the value that is found on position 7. So this means that we have 128 as the value is equal to ar to the power of 7 minus 1, because we're seeing T7. This means position number 7. Then 128 is equal to ar to the power of 7 minus 1 gives us 6. Then this is the second equation. Now, it may be complicated to come with how we are going to solve this. Now, let's write equation number 2 just below equation number 1. 128 is equal to ar to the power of 6. Then, this is the second equation. But here's something that we can come with. We can say that equation number 2 divided by equation number 1. In most cases, a geometric sequence has a lot to do with division. So now we're going to say that 128 is equal to ar to the power of 6 divided by, okay, what is the term? What is the left hand side in the first equation? That is 4. Then divided by ar. I hope you understand that. Then we're going to say that 128 divided by 4. Let's divide it. 128 divided by 4. That gives us 32. This means that 32 is equal to, well, if you can notice, r cancels the r. We are left with r to the power of 6 divided by divided by r. Remember the law of exponents that says when you are dividing the same bases, you keep the base and you subtract the exponents. This is the same as r to the power of 1. So we are going to say that 32 is equal to r to the power of 6 minus 1. That's what we mean when you say you keep the base, that is r, and you subtract the exponents. This means that 32 is equal to r to the power of 5. You can take the fifth root on both sides. That is 32 here, and you take the fifth root again on r to the power of 5. This means that r is equal to 2. You take the root depending on the number that is here. Depending on the number that is here. If this was r squared, you're going to take the square root. If this was r to the power of 3, you're going to take the cube root. But because it's r to the power of 5, you're going to take the fifth root. I hope that makes sense. So, we're going to plug r to the power of 5. We're going to plug r equal to 2 inside one of the equations, either 1 or 2. But equation 1 is more simplified. Remember that we said that equation 1 was equal to 4 is equal to AR. So we're going to write it. Equation 1 goes as 4 is equal to AR. Then we're going to say that 4 is equal to, well, we are looking for A. R is 2. And we're going to divide both sides by 2. We divide both sides by 2. The 2 cancels the 2. 4 divided by 2, that gives us 2. And is equal to A. This means that A is equal to 2 and R is equal to 2. Then your equation, it becomes Tn is equal to the first term, that is A, that is 2 multiplied by R, that is 2 to the power of n minus 1. And we have answered the first question. I hope that makes sense. If you don't understand, repeat the video and make sure you understand every single step that has been made in this video. Now we are moving to the second question. Let's write number 1 here. Number 1.1, the answer was Tn is equal to A. A was 2. Was equal to 2 to the power of 2 multiplied by 2 to the power of n minus 1. That was 1.1. Then 1.2 says, determine the value of the 90th term. This means we are looking for T90. T90. We are looking for the value. This means we are going to plug 90 where we see n, since we are given position this time. Then T90 is equal to 2 multiplied by 2 to the power of 90 minus 1. And let's plug that in the calculator to see what we get. To the power of 90 minus 1. That gives us, oh, it's quite a huge number. I'm going to write it in scientific notation. That is 1,24. 1,24 multiplied by 10 to the power of 27. That's a huge number. Then again they say 1.3. Which term has a value of 2048? Meaning this time we are solving for n. They are saying which term has a value. We are given the value. We are given Tn. We are looking for n. Let's plug Tn that is given. That is 2048. We're going to say that 2048 is equal to 2 multiplied by 2 to the exponent n minus 1. We are plugging this inside the formula which we have found in 1.1. When you are here, you can divide everything by 2. These 2. Let me show you. These 2. You divide everything by the coefficient here. So we're going to divide by that coefficient, both sides. Then the 2 cancels the 2, but the 2 that is attached to the exponent is not divisible. Do not divide it. That is not mathematically correct. Then we're going to say 2048 divided by 2. 2048 divided by 2, that gives us 1024. That's 1024. 1, 0, 2, 4 is equal to 2 to the exponent n minus 1. Since you have not been introduced to log, I'm going to show you how log works. If you have, let's say, an expression b is equal to 2 to the exponent d. If you want to solve for d, what you will do is that your d becomes what? Your d becomes the left side. Your 2 becomes the base, and the b becomes the number. What we're going to do here, we're going to apply logs. This goes as, we're going to say that the left side is d. d is equal to log, base is 2, the number is b. Follow the same procedure to write the expression, this one. So which one is going to become the left side? The left side will be the exponent there. That will be n minus 1. So we're going to say that n minus 1 is equal to log, the base will be 2, and the number will be 1024. Then here we're going to say that n minus 1, plug everything that is on the right hand side on the calculator. That is log. Log is the one that is below the on button. It's log 2 and then 1024. That gives us 10. And then you're going to take the negative 1 to the right hand side and will change its sign. This means that n is equal to 10 plus 1 and is equal to 11. This means that you will find the value of 2048 on question number 11. Thank you for watching. Bye bye.